Let's take a look at the second limiting reagent example problem. So here it is. We've got this chemical formula up at the top. And it says if 100.0 grams of Fe3O4 and 10.0 grams of H2 are reacted, how much Fe is produced? How much excess reagent is left over? All right, so we start off, number one, balanced chemical reaction. It's right here. It's balanced. It's 1, 4, 3, 4. Good. Let's identify what we know and what we're trying to find out about. Well, we know we've got 100.0 grams of this guy. And we've got 10.0 grams of that guy. We want to find out about this guy. All right, so what's the problem here? The problem is that we know two reactants. We need to determine which one gets used up completely and which one is left over. So we need to start off with our limiting reagents. So to do that, first we have to find the moles of each one. So I'm going to write out a map here to find the moles. So I got the mass of Fe3O4. And I want to find the moles of Fe3O4. And this is 100.0 grams. Okay, so I need my molar mass of Fe3O4. Fe3, where is Fe? That's iron, isn't it? It's 55.933. 55.933 times that by 3 of them plus 15.999 times 4. There's 4. And we get 231.795. Okay, so how many moles are there in 100.0 grams if 1 mole has 231.795 grams? Right, write out my conversion. Barely looks like 100 decimal zero, but it is. 100 divided by my molar mass. And we get 0.043141569. I wrote down the whole thing. This guy is 4 sig figs, so we should carry 5 sig figs at least. 1, 2, 3, 4, 5. I just wrote down a couple more. All right, so that's the Fe. Now let's do the H2. We know our mass of H2, which is 10.0 grams. We're going to figure out our moles of H2. Right, so how many moles are there in 10 grams if 1 mole has 2.016 grams? That's one I just have memorized because I've been doing this a lot. And we get 4.960311746. Okay. Now remember, this line is our reality line. This is how much we actually have. So this is actual. Now we have to do our 2 pretend scenarios. Scenario 1. Pretend Fe3O4 is used up. That's scenario 1. Scenario 2 is we're going to pretend H2 is used up. Right there are 2 scenarios. So for the Fe3O4, we can have our moles, Fe3O4, and that's 0.43 ... It's just right up there. Then we're going to go through our molar ratio to figure out how many moles of H2 we would use. And our molar ratio comes from our chemical reaction. It's 1 mole of this to 4 moles of H2. All right, so let's do this. So how many moles H2 are we going to get for 0.43141569 moles of that if there's 4 moles of H2 for every 1 mole of that? So we just take our 0.431 and we times it by 4. And we get an answer of 1.72566,276 moles. So we pretended all of our Fe3O4 was used up. Now over here, we're going to pretend that our H2 gets used up. So let's look at here. We've got our moles of H2, which is 4.96 ... And we're going to figure out how many moles of Fe3O4 it would take to use this up. We're going to use our molar ratio. Our molar ratio this time is 1 to 4. Right, from up here on our chemical reaction. So we write out how many moles of Fe3O4 are required to react with 4.96 ... moles of H2 if the molar ratio is 1 mole to every 4. 4.96 times 1 divided by 4. So I have this 4.96 already in my calculator, and I divide it by 4, and I get an answer of 1.24007937. Now let's see which one of these situations is possible. Is it possible to use up all of our iron oxide? Or is it possible to use up all of our hydrogen? So let's check our iron oxide. We have this much iron. It's right there. We have this. This is a real thing. We have it right here. Do we have this much H2? We're looking for 1.72 to use it all up, and we have that. We have 4.96. So yes, we're going to use all that up. Let's look at the other one. Do we have this much H2? Yes, we do. This is good. Do we have this much Fe3O4? Well, we need 1.24, but we only have that. So we do not have this amount here, so this cannot get used up. So the situation that is real is Fe3O4 is limiting, and H2 is in excess. Okay, those are our two situations. All right, so now let's finish off our stoichiometry over here on this side. We're going to go from we always use our limiting reagent, this one, in our stoichiometry. So we're going to go from our moles of Fe3O4, and that's 0.431 ... It's that number up there. Then we're going to go to our moles of Fe. Then from there, we can go to our mass of Fe. Okay, so our molar ratio from the chemical reaction is 1 of Fe3 to 3 of Fe. So it's going to be 1, 2, 3. 1 to 3, like that. All right, so let's do this up. How many moles of Fe will I get if I'm using 0.431 ... moles of Fe3O4 if my molar ratio is 3 to 1? Right, 3 moles of Fe to 1 mole of Fe3O4. So we take this number, we multiply it by 3. I like my calculator, it's got a memory in it, so I just can pull down that number and times it by 3. I get 1.2942 moles of Fe. All right. So next we're finding out our molar mass. So how many grams of Fe are in our 1.2942 moles of Fe? And all this should have 4 significant figures because our number at the start had 4 significant figures. If Fe has 55.933 grams in 1 mole. So I take my 1.29 and I times it by 55.933 and I get 72.3139 grams of Fe. That's my answer to the correct number of significant figures. Now we have to find out how much H2 was left over, how much excess reagent. H2 is excess. So to figure out our excess reagent equals the amount we have subtract the amount used. Okay, so we're doing this for our H2. So we've got excess H2. So how much H2 do we have? We have this many moles. So we have 4.96031746 moles. Subtract. How much did we use up? Well, we used up this much over here from our working side, right? This side worked, so we used up all of our Fe3O4, and to use up all of our Fe3O4, we used up this many moles of H2. So we take away 1.72566 to get the amount of our excess H2, and this answer will be in moles. And we go, I've got those numbers in my calculator still. Fortunately, I've got that one. Subtract this 1.71, 3.23. I'm putting that to 3 significant figures because my moles originally had 3 significant figures. My mass of H2 had 3 significant figures. So this is how much leftover hydrogen gas we would have. Right, so finding the limiting reagent, you have to figure out the moles of both reagents, both of the reactants. Then you pretend that you use each one of them up and you figure out how much of the other one would get used. You decide which one's real and which one can't work. This one was real, we had both. This one can't work. You use your real one to continue on your stoichiometry. And at your other one, you can figure out how much excess reagents there are. Okay. So this is a limiting reagent question. This is a full limiting reagent question. With the way I write it out, it takes up a page. There are quicker ways to write it out, but I'm doing this for understanding, not for speed. This question should take about 10 minutes. When you're working at it without explanation. All right, so that's all on limiting reagent. That's how to do it. We'll take a look at it in the next homework. Thank you for watching.